Okay, my children, I'm teacher Geeta. This is grade 11 physics topic, gravitational field. The last video I explained about the motion in circle. I think all of you understand and all of you know everything about that lesson. Okay, now we are going to give an explanation about gravitational field. But we are familiar with the fact that Earth's force of gravity is responsible for our weight. The force which pulls us towards the Earth, and that is the gravitational force. And you know that the famous scientist Sir Isaac Newton concluded that the Earth's force of gravity is also responsible for keeping the moon in its orbit. And you know that in solar system all the planets are stay in their orbit because of the gravitational force of attraction between the sun and the planets. And we now know that every mass attracts every other masses. This force is known as the force due to gravity or gravitational force. What is meant by gravitational field? The gravitational field is a region of space where a mass experiences a force. And here it is the picture showing how the gravitational field lines show on which way the object within the field will move. But here from the tree it is coming down. If anything you are throwing upwards, it will come down only. But here it is gravitational field lines in space pull masses towards the earth. It is towards the center of the earth. This is about gravitational field. Now we have to discuss about the Newton's law of gravitation. Isaac Newton showed that the earth's force of gravity extends into space, but weakness with the distance according to an inverse square law. But this way he is using this inverse square law, Newton's law of gravitation. He explained about the gravitational field. But the law states that the 2 point masses attract each other with a force that directly proportional to the product of their masses and inversely proportional to the square of their distances. So we have to say that if proportional to m1 into m2, f directly proportional to, and f proportional to 1 by r squared, or f inversely proportional to the distance between them. And after changing the proportionality sign, we have to write f is equal to g m1 m2 by r squared. G is the universal gravitational constant. M1 and M2 are 2 point masses. It attract each other. R is the distance between them. The law states that F equal to G M1 M2 by R squared. F is the gravitational force, G gravitational constant, mass of first object, mass of second object, and the distance between the masses. Or instead of D we have to write R also. And G has the measured experimentally. The value is 6.673 multiplied 10 to the power minus 11 Newton meter square per kilogram square. This is about Newton's law of gravitation. Now the speed of satellite orbiting the earth. This is a circular motion. You can solve the satellite orbiting speed using the following equation. See, V is equal to root of Gm by R. And here it is, see, the earth, a satellite is orbiting towards it. Remember this one. Here also the R orbit, radius of the orbit radius. You have to find the orbit radius. If you want to calculate some questions like this, and what is the radius of the orbit? So earth radius plus the height of that one. That is the earth orbit. Remember that one. After plus only you have to calculate that one. But here it is. You know that centripetal acceleration is equal to A equal to V squared by R. Force is equal to M. That is the Newton's second law. Then velocity is 2 pi R by T. Force G m1 m2 by R squared. All these are given, and here it is giving. You have to how to derive this equation. You see here a star has a mass of this much and the radius and the planet, and then see. Determine the speed at which, and here it is they are finding the speed with planet or with the star. This way they V is equal to 5.610 to the power 10 meter they get. And here from you have to write how to find the speed of the satellite. This force net force, the total force is equal to gravitational force here. So if this is equal to mv squared by r, here we have to write g m by r square, and here m cancel, here r cancel. From this we have to write v squared is equal to gm by r. So v is equal to root of gm by r. This way we have to derive this equation. The speed of a satellite orbiting the earth, v is equal to root of gm by r squared. Now gravitational field strength. The gravitational field strength at a point is defined as the force per unit mass acting on a small masses placed at that point. See the point masses. If it is a pointed sphere, if you have this uniform sphere, the center we have to say that is the point mass. And here field strength G, the gravitational field strength G is the gravitational force per unit mass on a test mass. This is the equation. G is equal to F by m. F is the gravitational force, m is the mass of the test mass. G is a vector in the same direction of F. The unit of G is Newton per kilogram. That's all, okay. Now gravitational field strength on a point mass. Gravitational field strength G is defined as the gravitational force per unit mass. But here it is the equation G is equal to F gravitational divided by m. By considering the gravitational force on a small mass m from a large mass m, can you derive the following formula? See, for the gravitational field strength of a radial field. For radial fields, G is equal to Gm by r square. We start with the equation above. Force, gravitational force equal to mg, mass into gravity, and then use the formula for the force between 2 point masses. Here you know that the force between 2 point masses G m1 mm by r squared. For rearrange the equation, you have to write F gravity is equal to mg is equal to G mm by r squared, and cancel have to m, so G is equal to Gm by r square. This way you will get gravitational field strength of point mass, that is G is equal to Gm by r square. Now gravitational potential. The gravitational potential at a point is the work done per unit mass on a small point mass moving from infinity to that point, which is given by the equation V is equal to minus Gm by r. Okay, but this is showing that one potential energy earth. See, this way the distance is moon is there. For gravitational potential, I think my children already explained this lesson. Now you watch this video, you clearly understand this. Remember all these equations. Okay.